All right, so here we go. So we're in 4.6. It's all about factoring. So I think you guys already know how to do this one. I don't think you need me to do anything. So let me just give you a second. Go ahead and factor that one, as you already know how to do. You know, with the diamond thing, all that. Can you do that real quick? Maybe it's been a little while. Remember, you do the diamond when you have three terms. And, oh, actually, you know what I should have said is what's in common to all the terms, huh? Nothing, but it's good that we look for it. You know, first is GCF. There's nothing in common. So then you go right under the diamond and you say what multiplies to be the positive 9, what adds, remember it's multiply to be the back number, add to be the middle number. So what two numbers multiply to be 9 and add to be negative 6? Yeah, 3 and 3, both negative, huh? Because two negatives multiply to be positive and they add to be a negative 6, a bigger negative. Okay, and so what do we do then? Well, that's the factorization. It's going to be x minus 3, huh? Really, that's the answer. That's a fine answer. You could say it more simply if you want to. How could you say that same answer more simply? Yeah, it's when you have identical twins, you can just say squared, huh? You can just say two of them like that. Yeah, so really, that's not new at all. Not at all new. Now, the second half of the section is. So I'm going to skip a bunch of basically problems. I think it's like 1 through 9, 8 or 9, something like that. 1 through 9 are not new. They're just like this one. They're just same old stuff you already know. So I'm going to skip over them and just jump to the stuff that is new. Just wanted to show you that first off, though. It's actually 1 through 8 are not new. And then it's starting at number 9. It is new. So let's write that one out. 9. X squared minus 9. They want us to factor. Okay. So we're still now. This is going to be new, but it's going to be easy new. This will be your favorite factor. So this will be the easiest factor we do. So how do we factor? Notice what's different here. What's different between number 9 and then number 1 that we just did? Only 2 terms instead of 3. Does everybody see that difference? See how this one has 3 terms, and so you know you do the diamond thing, and you know it comes out to be factorable like that. So most of what we've been doing for quite a while over last week has been 3 terms, huh? 1, 2, 3 terms. Well, this one only has 2 terms. So how do we factor when it only has 2 terms? Yeah, that's right. Good memory. Yeah, 2. I'm going to just jump. I'm going to kind of factor it the same as that I do for 3 terms. Just do the 2 parentheses like that. Okay. And what do I put in the front and the front to make the front? X and X, huh? And what do I put in the back and the back to make the back? Got to be 3 and 3. And what signs do they need? 3 times 3 is 9. But what signs do they need to multiply to be negative 9? What times what's negative? 1 positive, 1 negative, huh? Does that make sense? Doesn't matter what order. You can put positive first or second. Either way, doesn't matter. But it's got to be one of each, doesn't it? 1 positive, 1 negative will multiply to be negative 9. And we're done. That easy. These are just super easy. They're just really quick. You don't even have to do the diamond or anything. So when you only have 2 terms, it's really, really quick. You might wonder, I would if I was you, I'd be thinking, well, why does that work like there's only 2 terms? You know, if you checked it, do you know what's going to happen? It's like Claudia's saying, the middle term is going to be 0. That's what, let me show you. You don't have to, not require, we're done. I mean, we're done there. That's the answer all over. I just want to prove to you that it really is true. If you were to multiply this out, it would actually go back. Let's see it. Because it would be x squared, right? X times x. Minus 3x. That guy's done. He went to both. And then, then this guy will go to both. Plus 3x. And then plus 3 times minus 3 minus 9. Well, do you see what would happen in the middle? These would cancel out, wouldn't they? And see how it just goes back to x squared minus 9? So it's right. It's basically like a 3-termer where the middle term is 0. That's basically what it is, isn't it? That's why there's only 2 terms, because the middle term is 0. That's all. So anyway, you don't have to worry about all that. Just do 1 plus, 1 minus. It'll be good. Let's try one of these. So b squared g squared minus 49. So number 10. B squared g squared minus 49. Can you factor that one? Same kind of thing as the one we just did. So 2 parentheses. Front times front to be b squared g squared. What's that? What times what's b squared g squared? bg, bg. Is that okay first off? And now what goes in the back and the back to make minus 49? 7 and 7. What signs do we need? 1 plus, 1 minus. Either or, you can put the minus first and the plus, doesn't matter. This making sense? It's the easiest kind of factoring, huh? All right, let's try another one. How about 11, 2a t to the 4th. Okay. 2a t to the 4th minus 2a m to the 4th, is that right? Yeah, that's a hard one. Okay. What's the first step on every factoring problem? GCF, yeah, so do that first. Remember how we always do that first, no matter what else we're going to do later? Always, if there's something in common, do that first. So first, GCF. Yeah, so first, take out the GCF. So what do they both have in common? 2a, huh? Yeah, so do that first, and then from there, then you'll go on to the 2 parentheses on the next step, huh? Remember how that always works? With GCF, we take out what's in common, do the 1 parenthesis, and go on to the 2. All right, so if you take out the 2a, it's going to be t to the 4th minus m to the 4th. Is that good? Now, what do we do from there? What am I going to do with t to the 4th minus, front times front to make t to the 4th? Yeah, t squared, huh? And then back times back to make m to the 4th. M squared, m squared. And how do they make negative m to the 4th? 1 positive, 1 negative. Now, are we completely done? We can do it again. Do you see that we can do the same thing again? You know what I mean? What am I talking about? Well, let's bring down the stuff that's already there. So bring down the 2a. And then, do you see how, there's a couple things I need to tell you. Basically, this guy will not break down further because he has a plus in the middle. I know I haven't told you about that yet. I'll spend some time talking about that. But for now, let me just say, he doesn't do anything else. But this guy will break into 2 parentheses. I'm going to use a different color just to emphasize it. And there'll be t times t, m times m, 1 plus, 1 minus. Now we're totally done. Like that. How are we doing? Is that making sense? There. Now let me explain why. Why does this guy not break down? Only the minus breaks down, not the plus. Only the minus, not the plus. Let me write that up here. Basically, if you have, I call these a double-double. I like In-N-Out Burger. I call these a double-double. It's just an easy way to remember it, too. If you think about t squared minus m squared, I call that it's two t's, two m's, right? Double, double, that's why I nickname it that, double, double. If you have a double, double with a minus in the middle, that's not the official math terminology. It's called a difference of squares, is what it's called. They're squares, they're doubles, right? It's two t's, two m's. Anyway, when you have that, you put the t's in the left, as you know, the m's in the right, 1 plus 1 minus. That's correct. But why? Because you would be natural to think, well, you just do the same thing for plus. I mean, if you have t squared plus m squared, that's a double double. Can't we just do the two parentheses and just put t's in the left, m in the right, and just make them both plus? You might think, right? Both plus would make plus m squared, wouldn't it? Why isn't that correct? Well, the bottom line is if you FOIL that out, which I'll now do, you'll see it just isn't right. It just doesn't. It ends up throwing in an extra middle term. Let's see it. If I was to actually check that, if I thought that was correct and I was going to check it, I would go, okay, let's go to both. What are we going to get? T squared plus TW. Okay. And then this guy's going to go to both. Oh, that's an M, huh? My writing made it look like a W. TM. Anyway, plus TM plus, what's that last one? M squared. Can you read all that? Sorry, I'm getting kind of scribbly up there. Yeah, I don't have room. Let me write this a little better. Let me just make it with X's. How about that? I'm just going to do this really clearly. I'll put plus here. I'll put minus here. Let me prove that this one's really right. This one's X plus Y, X minus Y. Get the idea? This is correct. Let me check it. If you check this one, you'll see that if you FOIL it like that, you're going to get x squared minus xy, boom, boom, plus xy minus y squared. See how those cancel in the middle? And you just get x minus y squared. X squared minus y squared, check it. It works. It's right. Whereas on the other side, if you think it's x plus y, you can quickly prove it's not by just saying, what if I was to FOIL it? You'd get x squared plus xy plus y squared, which, see how the middle don't cancel in this situation? They don't cancel. In fact, they add. 1xy and 1xy would be 2xy. They're like terms, aren't they? And that is not the same as the start, is it? So it's not right. Does everybody see that? So it's just simply not true. When there's plus in the middle, that ruins the whole thing. So you really need to remember, so they're going to test you on that like 5, 6, 7 times in this homework. They'll keep baiting you. They're throwing the hook out there. Hey, how about you do it on the plus? And you have to know. So I'll maybe just write that on the board. Just keep that super clear. Does everybody see that? Because there's so... Coming back to this question. So that's why this one right here that has the plus in the middle just stays as it is. It's still part of the answer. We don't get rid of it, but it just doesn't break into two smaller things. Whereas the one over here does break into these two smaller things. Well, then how do you know? You might wonder, I would, if I should have you think, well, how do you know when you're done then? Well, basically we're done because this one has plus, so he can't go anywhere. And these guys are done because they're just first power now. So they can't break smaller. Up here they were squared, so they broke smaller. But now they're first power, we're done. Does that make sense how I know I'm totally done at that point? Questions? Is that good? So a lot of steps there. First step, take out what's in common, then break it into two, and then the minus one goes again. Okay, so you want to try that one real quick. Factor that one. So first, GCF. What is the GCF? What do they both have in common?
5.
The 5, huh? Take out the 5. I see now. So let me help. So because I think you get the general idea. So the 5. So basically anything that doesn't change drops down identical. So notice that 5. He's going to stay there. He's not going anywhere. You got to have him. You can't lose him and leave him up on a previous line. He's got to be there still. And then this guy is going to break into half, huh? with the two parentheses, and it'll be x4, x4, because that makes 8, right? And y4, y4, because that makes 8. How do you get negative y to the 8th? 1 plus 1 minus. Good so far? Right, because positive times negative makes negative. Now, here's the part I really want to show you. Now, what's going to happen from here? The 5 comes on down. He's got to be there. Now, what about this plus? Looks like you all know the plus isn't going to break down. But don't leave him out. He's not going to vanish. He'll just come straight down. Identical, no change. That makes sense. He's still got to be there. So just bring him down. Don't leave him. Does that make sense? And then this guy will break into 2 smaller, won't he? He'll break into 2 smaller. He'll break into x squared, because he's a minus. X squared, y squared, 1 plus 1 minus, because positive times negative makes negative. Does that make sense? So the plus things drop straight down, no change. The minus breaks into 2 smaller. 1 plus 1 minus. Is that good? And then one more line. This guy's going to drop down. These 2 plus guys are going to come straight down, no change whatsoever. And then the minus break into 2 smaller. 1 plus 1 minus. Huh. That makes sense? So just bring this straight down. Bring this straight down. Bring this straight down. And this guy will break into 2 smaller. Won't he? X and X, Y and Y, 1 plus, 1 minus, all done. How do we know we're all done? Well, these are all plus. They're not going anywhere. This is the only minus that might go further, and he's just first power. So he's done. How we doing? Good there? See how this works? So you just keep breaking down the minus piece into 2, and the minus piece into 2. And the other stuff just drops straight down, stays as it is. Questions I can answer on that? All right, I'm going to move on if you're good. 1/9 minus v squared. What have we learned about negative, about who we want in the front? We want the letters in the front, don't we? We always want the letters in the front. So, well, actually, you know what? You don't have to on this one. Just leave it as it is. Yeah, forget about that. Just do the regular thing. This is another double-double. Just leave it as it is. It's all good. Okay, let me help. So, what I'm saying is you can just go straight down. Front times front to make front. You got to keep the order as it is. You can't switcheroo. So what times what makes 1/9? 1/3 times 1/3. Is that good? Right? When 2 fractions multiply like that, 1/3 times 1/3 being 1/9. And v times v. What signs do we need to make minus v squared? 1 plus 1 minus, huh? And we're done. How are we doing? Yeah. Yes, you could do that. It's not required for 2 terms. For 3 terms, it is. Yeah. So, good point. You could, if you, I'll say, or you could swap them around, because remember how we said we like the letters in front. I hope I don't confuse you by this, but this is another option. You could switch the order. Remember, when you move things around, you take the signs that are with them. So that minus sign would go with it, and then the 1/9, not 9, 1/9 has a plus sign in front of it. And then you can't have a negative in the front, so you'd have to factor out a -1. Remember how we learned that? See, this would be harder. You'd have a couple fancy rules. And then finally you'd do the v, 1/3, 1/3, 1 plus, 1 minus. That's the same answer, it turns out. And Math Excel knows, and it'll give you credit for either one. Both are right. Anyway, that's probably confusing. This is fine. Just do that. It's good. All right. Now that one's going to be a little harder. What have we learned to do with 4 terms? Remember the 4-term ones? Grouping, yeah. Remember grouping? Like you do the first 2, and then you do the last 2. Use your calculator. 196, big number. Give you a... Okay, let me help with this one. So the first 2, so we have 4 terms. We do a 2-2 split. First 2. What do these 2 terms both have in common? B squared leaves b minus 49. Good so far? If I was to multiply, boom, b cubed, boom, 49b squared, right? Okay. Now the back 2, what do they both have? Well, you can use your calculator. It turns out that 196 is divisible by 4. I think it's 49, isn't it? So that means you can now watch out. Here's a mistake that's easy to make, is to go, okay, yeah, just take out a 4. It's b plus 49. That's actually wrong. It's very close to right, but it's wrong. What's wrong? What have I done? Yeah, remember me talking about not losing my baby, right? Signs in front of something, that's their baby. You don't leave your baby behind. You take it wherever. So that we can't lose our baby. That's a big deal if you lose your baby. So that minus needs to stay there. That's really, really important, and that will change the dynamics of things. So that negative needs to be there, and that'll actually make this minus 49, right? Because minus times minus will go back to plus. Okay? And not only that, that also tells us we're not done. It's a loose horse. Remember that analogy I made? That minus sign tells you you're not done. You have another step to go, and it tells you a lot how to look at it. It says, look, that's the separator. Remember the pluses and minuses outside of parentheses, the loose horses? They're the separators also. They separated into 2 sections, which it kind of tells you how to look at it. So that's how you should be visualizing it. Okay, so what? What do I do now? What do they both have in common? Yeah, that parenthesis b minus 49. Does that make sense? I want to make sure that's really clear for you. What if I had b squared x minus 4x? You all would know how to factor that, huh? What would I put in the front? What do they both have in common? X, huh? They both have an x. Then I would remove it, and bring down the b squared minus 4, wouldn't I? Because that 1x could go back, right? Well, that's exactly what we do, but instead of an x, it's a whole parenthesis b minus 49. It's just a bigger x. It's the same idea, though. They both have it the same, don't they? Like these guys both had an x. These guys both have a parenthesis b minus 49. It's just a bigger version of the same idea. When 2 terms both have the same thing, whether it's a little x or a big old parenthesis b minus 49, whatever, the game remains the same. We remove it, like I remove the x, put it in the front, right? And then I did what? Start a new set of parentheses and bring down the leftovers. B squared minus 4. See how that's the same thing as we did with a simple x? It's just a big parenthesis b minus 49. They had in common. They both had one. Remove it, put it in the front, and then bring down the leftovers in a new set of parentheses. Okay, now, and we're virtually done, which means we're not really done. What more can we do? Yeah, what you want to train your eye to do is to look for anything with a higher power and think about breaking that down another step. So this guy right here, I don't even worry about him. He's done because he's just b to the first power, huh? He's not. He's just going to come straight down. He can't get smaller at all. He's already as low as his power can get. But this guy can get smaller. He's a square. So what's he going to do? Break into 2, right? B's in the front, 2's in the back, 1 plus, 1 minus. Now we're done. See, they're all regular B. And so there we go. How are we doing? Questions on that one? Is factoring stuff making sense? No questions? All right, let's just keep practicing. It just really that one. Let's see what you can do there. Let me help. I know this can be tricky. A lot of the trick, you know, in math is seeing the form and being able to do the form even when they make it big and ugly. What do I mean? Let me show you. If somebody gave you x squared minus 9, just like that, or let me just make it w squared. Somebody gave you w squared minus 9. You could do that with the greatest of ease, huh? You would know exactly how to factor that. What would it be? 2 parentheses. W's in the front. Why? Because w times w is w squared. And then 3's in the back. 1 plus 1 minus. Done. Piece of cake, right? That's exactly what this is. It just looks bigger. So let me help your eye to see that that's exactly the same thing. It's just bigger version. They're just trying to fool you by making it bigger, but the format's the same. What do I mean? Let me show you. Let me just do it with triangle minus box. I hope you don't feel like we're in kindergarten. We're not. I would do this for calculus students. This is math is the science of patterns. It really is. Well, what is math? You know, I don't know if you ever stay up late at night worried about that. I'm sure you don't. But weird math teachers do. And I think, what is math really? Math is the study of patterns. Getting and growing in math ability. You know, why do we make people take, or we, the state of California, you know, the nation, make people take math, even if you're like, I'm going to become a, you know, English, I'm going to be a journalist, or I'm going to be, I'm not going to do math. Why do I need? Well, what math really does is teaches you to be better and better and better at patterns. Even if you're not going to, you know, use algebra or, you know, physics or whatever, it teaches you patterns. Math teaches you to recognize patterns, predict patterns, describe patterns, manipulate patterns, which is what a lot of jobs involve, is good pattern skills. What does a doctor do? He or she looks for patterns in the symptoms of a patient, right? When they recognize a certain pattern, they match that up with a condition and provide a treatment. What does a lawyer do? Just to pick 2 random professions, doctor and lawyer. What does a lawyer do? They look for patterns in the law. They actually have a word for that, right? They call it, I can't remember the word now. There's some kind of word, right, when they refer to old rulings that followed this same idea, and then they apply it to new. That's a pattern. That's looking for a pattern. Anyway, so the ability to deal well with patterns is a valuable skill in all kinds of situations. So that's what we're doing. That's really what we're about. So what do I mean the pattern? Well, the pattern is this. If you have something with a 2 on it and something with a 2 on it, whether it's a triangle in a box or a W and a 9, whatever, you always do the following pattern. You do 2 parentheses. You put the triangle in the triangle. You put in the left, and the box in the right, and 1 plus 1 minus. That's the pattern, huh? Again, that's not kindergarten. That could be calculus. I do this for calculus students at times when they're getting confused by the veneer of things, the big ugly look, and they're forgetting the essential pattern. That's the essential pattern. Do you see it now? This is a big old triangle with a 2 on it, and this is a box with a 2. How is it? It's 3 squared. That's what that really is, huh? 9 is 3 squared. So what does that mean? So what? Well, that means you follow the pattern. What do? You put 2 parentheses, and you put in the left of each one the thing without its 2 power. The thing, x plus y, without its 2 power. Right? Because x plus y times x plus y is x plus y squared. And what do you put in the right? The thing without its 2 power, right? The box without, I'm scribbling it, without its 2 power. 3 and 3. Would it help if I change color there? Right? Put in this is 3 squared, so you put a 3 and a 3, huh? Isn't that the pattern? Whatever's on the right, you put right and right without the 2 power. Because 3 times 3 makes 9. Huh? How do you get negative 9? 1 positive, 1 negative. Done. See how that's the same pattern, it's just bigger? See how they're trying to fool you by just making it bigger? But it's the same pattern of the 2 parentheses, 1 plus 1 minus. Is that good? Does that make sense on that? That is essentially what we're doing all this math for, is to get you more and more comfortable with dealing with patterns. So try to look into these things and look for the essential pattern. That's what we're doing. All right. Good. Questions on that one? And how do we know we're done with this thing? What's that? Yep, they're all first power. All the horses are contained. All the plus and minuses are in parentheses. So we're done. Yep, for those good 2 reasons. Yeah, I didn't realize we were already there. All right, the 2-2 thing is not going to work. Let me show you that it doesn't work, and then I'll show you the right way to do it. I'll just even tell you now, you got to do 3-1 instead of 2-2. All right, but let me show you why. Why does the 2-2 thing? Now, normally we do first 2, last 2 when we have 4 terms, right? First 2, last 2. Well, so you just pretend the whole problem is the first 2. Let me just get rid of this for a minute. What if the problem was just those first 2? What would you do? Take out a C, huh? They just have C in common. Leave C plus 2Q. Okay, that's good so far. It's not going to get us anywhere, but that's right so far. And then we got plus, what was it? I erased it. Plus Q squared minus. Okay, now, what if the whole problem was just, bring down the plus sign in the middle. You always, that sign in the middle is super important. So, what if the whole problem was just the last 2? What would you do with just the last 2? Well, somebody gave you a whole problem. Just please factor Q squared minus 4. What would you do? Yeah, you put 2 parentheses, yeah. Q, excuse me. Excuse me, I'm trying to time my sneezing here with the lecture. All right, plus 2 minus 2, exactly. Okay, so that's great and all, but now we would be stuck at a dead-end street with a loose horse running free. Do you see what I'm talking about? Remember, we know we can't stop here because that's a loose horse. Whenever there's a plus or minus sign outside of the parentheses, you're not done. You can't stop. You must do more. So, and I can't do more because this, and then that's the separator also. That loose horse tells you need to do more, and it tells you how to visualize it, how to separate it, right? And you say, look at do they have anything the same? No, they don't. They're close. You think, well, almost. This is like, Q plus 2. Yeah, but this is C plus 2Q. It's different, huh? They're not the same. There's nothing in common. We're at a dead-end street, and we're not where we're supposed to end up. So abandon this plan. So we need something new now. So notice that 2-2 doesn't always work for 4 terms. So now we're going to actually do, it turns out on this problem, 3-1. We're going to do those first 3 together. How do you know when to do this? Here we go. I'm going to give you the pattern again, right? It's like, yeah, I'm just giving you pattern after pattern. Well, let's just say, when the first 3 terms are x squared x, no x. Or in this case, c squared, c, no c. See how it's c squared, c, and no c at all? When they follow that format, those 3 are saying we go well together. Keep us 3 together. We're a pattern. Don't do a 2-2. Keep us 3 together. So when the first 3 terms are x squared x, no x, or whatever letter you have, c squared c, no c, then factor the first 3 by the diamond and the 2 parentheses. Does that make sense? Otherwise, you do the 2-2 thing. So just pretend the whole problem. Let me get rid of the minus 4 for a minute. Just pretend the whole problem is those first 3 for a moment. Just pretend the minus 4, I just erased it. Just pretend that minus 4, here, I'll just scribble it. Pretend it's not even there. Just do those first 3. How would you do those first 3? Well, that's going to be the 2 parentheses, right? What number's in the back? 1. So we're doing the diamond thing, right? What multiplies to be plus 1 adds to be plus 2 in the middle? Remember, the middle is always adding. The back is always multiply. So what two numbers times to be 1 but add to be 2? 1 and 1, huh? Plus 1 and plus 1. Does that make sense? They multiply to be 1, add to be 2. So that means this is going to be c in the front to make c squared. And q in the back, 1q to multiply to be 1q squared. Both plus, because that way they'll add to be the 2cq in the middle. Does that make? I'm not completely done. I got to bring down that minus 4, which really is there, and we got to do something about him also. But so far so good. You see how I factored those first 3, right? C times c is c squared. You know, back times back, q times q. And you don't need these 1s. You can get rid of the 1s. They're not needed. 1 times q. That's just q, huh? Right? Q times q is q squared. And so that is the factorization of these 3. That's the pattern we've learned for how to handle those 3. Good so far? Now, what do you do when you have 2 identical twins? Yeah, c plus q squared, right? You good so far? Now what? Are we done? Can we stop here? We got it. What tells us there's no way we're done? We've got the loose source. Plus and minuses outside of parentheses say, no way, you can't stop here. You're not done at this point. You got to do more. Well, what are we going to do? Do you see the pattern? It's the exact same pattern. What if they had given you, let me put it over here for a minute. What if they had given you x squared minus 4? You would know exactly how to deal with that, right? Right? The 2 parentheses, x is in the front, 2 is in the back, right? So, yeah, let me try it again. If you had x squared minus 4, you'd do 2 parentheses, you'd put x's in the front, 2's in the back, 1 plus 1 minus, huh? Well, it's the same thing. Instead of an x squared, you have a parentheses c plus q squared. Whatever. It's a little bigger situation, but it's the same exact pattern. You see it? You do what? 2 parentheses, c plus q in the left of each parenthesis, just like x in the left of each parenthesis, because c plus q times c plus q is c plus q squared. Right? Good so far. See how the pattern's the same? It's just bigger. And what times what is 4? 2 times 2. 1 positive, 1 negative to make negative 4. Done. And we're done because all the horses are contained. Everything's first power. So these are getting a little more advanced, aren't they? The patterns are expanding a little bit. They're getting harder to recognize. Can I help with that in any way? Does that make sense? Questions I can answer? All right, let's try that one. That one is tough. That one is really challenging. See what you can do there. So first, always first GCF. There's just not always something in common, but there is this time. 1 big old parenthesis, right? Divided by what? We will, but first, that's why it's so important. First GCF, then that other stuff. Yeah, remember, GCF is always number 1. Then other things later. Yeah, so now we're going to break it up, huh? Now there's 2 ways. We have 4 terms in there. There's 2 ways we've learned to break up 4 terms. We could either do first 2, last 2, or we could do first three. Now, how do you know? What was the rule I gave you back here? When the I'm erasing it. And when the first three terms, when the first three terms are x squared, x, no x, or whatever letter, then let those three be together. Otherwise, do a 2-2. Does that make sense? If the first three fit the form x squared, x, no x, then let those three be together. Otherwise, do a 2-2. So let's ask ourselves, do the first three fit the form x squared, x, and no x? Yes, they do. Those three, just like the last problem. We're going to do a 3-1, not a 2-2. You tracking with me? How are we doing? Are you with me? Am I doing the Charlie Brown teacher? Wah, 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 wah. You're thinking, what am I going to do this weekend? Stay with me. Just another hour here. Stay with me. It's really important. So 3-1 there. 3-1. Right? Because those first three are x squared, x. I don't care about the y. Notice how when I say that, I don't care if it has 10 million other letters. I'm just saying, does it have an x squared? Yeah. Does it have an x? Yeah, but it's also got, I don't care what else it has. Does it have an x? Yes, it does. Over here is there no x. We happen to come away, I don't care. Does it not have an x? Yes, it does not have an x. Well, then it's good. All I care, does it have x squared? Does it have x? And does it not have x? I don't care if it has a funny elephant there too. Whatever. If it's got x squared, x, no x, it fits the pattern. Do it. Those three go well together. Let those three be together. So that's 6. I'm just gonna move the 6 to the. Can I do that? I think the 6 kind of can mess you up and get in your way. It's gonna be part of the final answer. I'll just move it to the bottom. It'll be there. Now I'm just gonna focus on these 3. How do you factor just those 3? Yeah. Remember that front times front, x times x makes x squared, and then back times back to make y squared. It's going to be y times y. That's it, right? That will make the 2xy in the middle. If you FOIL that out, that will give you the whole thing. Minus 4w squared. Good so far? You okay with factoring those first 3? Get the hang of that? The pattern working for you? Now what? Let me give you another second. It's what we just did on the last problem, but I know it's not. So if you look back to what I did on the other one, when I have the 2 things, look back here. See what I did when I had the 2 things? I made it squared. So you make it squared. And then just bring the other one down. Is that good? Like that? Okay. Now, what do we do from here? What did I do back here? Once I had this squared and this, I went, just put the c plus q and the c plus q in the left, because that's c plus q squared. And the 2 and the 2, 1 plus 2, 1 minus 2, because that makes minus 4, huh? So that's what I do. I just put the 2 parentheses, and I put the x plus y, left and left, because that makes x plus y squared. And then right and right has to make the right. See how left times left makes left, and right times right makes right? Like that, right? What times what makes minus 4w squared? 2w and 2w, one positive, one negative, because positive times negative makes negative, 4w squared. Is that good there? And all the horses are contained, everything's first power, we're done. All right, cell 8. So now, this one is different. How do you know it's different than anything we've done up to now? Third power, not just second power, huh? It's not a double-double, it's actually a triple-triple. You probably shouldn't eat those in In-N-Out Burger. How do I mean it's a triple-triple? Well, b cubed, that's pretty obvious, b times b times b. And what about 8? How's 8 a triple? What times itself 3 times is 8? 2, huh? That's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, huh? So that's what we call, well, I call it a triple-triple. It's formally called a sum of cubes. It's a sum, it's an adding of cubes. It's a triple-triple. How do you factor a triple-triple? Well, there's a pattern, and I'm going to give you that pattern. So, here's what you do. In fact, let me just go to a fresh screen. Well, maybe I should do it on the same screen. Okay, so to factor triple-triple, or cubes, as they call it, sum or difference of cubes, what you do is, how about I do it with the triangles and the boxes and the thing? Well, let me just do it with an x. Suppose you have x, right this way. Suppose you have, well, let's do the, yeah, no, let me do the triangle thing. Triangle cubed plus box cubed. How do you factor it? Well, it turns out it's pretty tricky. It's a special pattern. You're definitely going to want to put it on your 3x5 card. Isn't our exam in a week? Don't we have a week? Where are we at? I think we have an exam in a week. Is that what you were hoping to hear? Yeah, it's next Wednesday is our exam number 2. So yeah, today we're going to finish the material that's on that exam. Anyway, here's the pattern you'll have on your 3x5 card. A little parenthesis and a big one. So you might think it would have like 3 parentheses or something. It turns out it doesn't. It just has one little parenthesis which has 2 things in it, and then a big parenthesis which has 3 things in it. So a little and a big, 2 things and 3 things. All right, and what are those things that go in those parentheses? Well, the triangle cubed means 3 triangles, doesn't it? And the box cubed means 3 boxes, doesn't it? So, in fact, let me change the color for that, just to be extra clear here. So I'm going to give you the pattern. Basically, you take one of the items from the left, and you put it in the left. One left. One of the items from the right in the right. No sign. I'll do the signs in the middle in just a minute. But first, I'm just going to place the things. So 1 left, 1 right. 2 left. Triangle times triangle. 2 right. Box times box. So far, so good. So I did 1 left, 1 right. 2 left, 2 right. And then in the middle goes 1 of each. Even though you might say, well, they're all done. Yeah, it's just a pattern. They're not really all done. There we go. Now, I haven't done the pluses or minuses yet. I will. But everybody good with that placement first off? There's the placement pattern on a triple-triple of cubes. Sum or difference of cubes. 1 left, 1 right. 2 left, 2 right. 1 of each in the middle. It's like a song. Very catchy. Maybe I'm exaggerating. But anyway, right? 1 left, 1 right. So one of the left items goes left. One of the right items goes right. 2 of the left items go left. 2 of the right items. See how the left stuff's always going left. The right stuff's always going right. 1 left, 1 right. 2 left, 2 right. 1 of each in the middle. And now for the signs. How do the signs go? Does anybody know this already? Claudia, do you remember this? Well, I got to pick on those that have had me in the previous class. It is soap. You soap the signs. Same, opposite, always positive. So meaning, whatever sign you started with, you could start with plus or minus. This one, by the way, works for plus or minus, unlike the double-double, which only works for minus. The triple-triple works for both. So you could start with plus or minus. It'll work either way. It just changes the signs. The placement pattern is the same, but the signs go same as what you started with. So if you started with plus, that would be the same. Opposite of whatever you started with. So in this case, that'd be minus if I started with plus. And at the back, AP, always positive, no matter what you started with. Same opposite, always positive. There's the triple pattern. See how math is just one pattern after the other? That's what learning math is about. Training you to be better and better and better with patterns. Same opposite, always positive. All right, so let's do it with the b cubed plus 8. Here we go. Little parenthesis and a big. And one left. One of the left items left. One of the right items right. Good so far. One left, one right. Two left items left. That's going to be b squared. Two right items right. 2 times 2 is 4. One left, one right. Two left, two right. What goes in the middle? One of each. A b and a 2. One of each, huh? One left, one right. Two left, two right. One of each in the middle. And now let's soap the signs. Soap. S-O. And there's three places where signs go. S, O, and AP. Same as what you started with, plus. Opposite of what you started with, minus. Always positive at the back. Done. That's how you do a triple. Same opposite, always positive. Soap the signs. Questions on that one? What's that? Is that it or what? That's final answer. Nothing more to do. Yeah, I know. Good question. Because usually we're used to looking at b squared and going further. That is the one really good thing about triple. The b squared part will never go further. You can mess with it, it won't work. It's done. You're just done. Whenever you do the triple, you're just like done right there. Even though the b squared looks like it would go further. If you tried fiddling with it, I can show you if it's helpful to you. Nothing will work. You might think, well, yeah, how about 2 and 2? That makes 4. And yeah, it does, but there's no way to make the middle right. There's no way to make minus 2. You can try the numbers over here. What multiplies to be plus 4 and adds to be minus 2? 2 and 2 makes 4, but how are you going to get them to add to be negative 2? There's no way. You might think, okay, we'll do 1 and 4. 1 and 4 can't make 2 either. They'd be 3. It never will work. It's nice. You're just done. Whenever you do triple, you are done right there. So is that pattern good? 1 left, 1 right, 2 left, 2 right, 1 of each in the middle. You always want to go for patterns when you're doing math. Just try to see the pattern. If you're taking math and science classes, it's all about the pattern. Is that good? All right. What number is it? What times this out 3 times? Yeah, 5 times 5 times 5. So we crank it out then. So little parenthesis and a big, right? And we go 1 left, 1 right, 2 left, 2 right, 5 times 5, 25, 1 of each in the middle, 5b, and then we soap the signs. Right, we good so far? 1 left, 1 right, 2 left, 2 right, 1 of each in the middle. Soap the signs, same as what you started with. I started with minus, huh? Same as that, opposite of that, so plus. Always positive at the back. Same opposite, always positive, done. We good there? With the triples? Questions I can answer? All right. All right, so try 23. First step in every factoring problem. GCF. Did you see it? Even here, always, never forget it. First GCF. What's it common? 5. Take that out. Use your calculator. Leave r cubed minus, is it 216? Yeah. 216. Just divide by 5 there on your calculator, right? And then, for that 216, use your calculator. I bet he's a triple. Yeah. Identify him as a triple he is. R times R times R. 6 times 6 times 6. So leave that 5 in the front. He's part of the answer. Right? Then you're going to have a little parenthesis and a big. Do the triple thing. 1 left, 1 right. 2 left, 2 right. 1 of each in the middle. Soap the signs. All right, so 1 left, 1 right, 2 left, 2 right, 6, 7, 6, 36. 1 of each in the middle. 6R. We good to there? Soap those signs. Same, opposite, always positive. Same as what you started with. What'd you start with? Minus. Same, opposite, always positive at the back. There we go. We good? All right. All right, try that one. Your first step is to recognize, well, GCF, there's no GCF, there's nothing in common. So right away, write that as a triple. Literally do that. Don't skip that step. I'm showing you that step. Write something 3 times that becomes v to the 6th. And over here, write something 3 times that becomes 8t to the 6th. Does that make sense? Do that first and the problem will be easy. Follow that pattern and it'll be easy. Okay, what times itself 3 times is v to the 6th? V squared, v squared, v squared. Remember, powers add, right? You with me so far? V squared, v squared, v squared is v to the 6th, isn't it? Because those powers add to go become 6, right? Okay, and what times itself 3 times? Now, do the right one. Write only 3 things. No, don't go 2, 2, 2, t squared, 2. No, that's 6 things. Don't do that. Write what instead? 2t squared, 2t squared, 2t squared. That's what you want to write. Does that make sense? That's 8t to the 6th. Because out front numbers multiply, powers add, don't they? Remember those rules? Out front numbers multiply, powers add. So there we go. So now, do the triple thing. A little parenthesis and a big. 1 left, 1 right, 2 left, 2 right, 1 of each in the middle. Soap the sign. Same, opposite, always positive. All right, so 1 left, 1 right, 2 left, 2 right, 1 of each in the middle. So 1 left, 1 right. Good. 1 of these left, 1 of these right. 2 left. V squared, v squared. 2 right. What is 2t squared times 2t squared? 4t to the 4th. 1 left, 1 right. 2 left, 2 right. 1 of each in the middle. 1 of each. What do you mean 1 of each? A v squared times a 2t squared. You can if it bugs you, you can rewrite it 2v squared t squared. It doesn't matter. It's all good. I'll rewrite it a little nicer that way. 2v squared t squared, right? Which 1 of each. And then soap the sign. Same, opposite, always positive. So we're going to do same as what we started with, plus, opposite, minus, always positive. There we go. See how that's 1 left, 1 right, 2 left, 2 right, 1 of each in the middle? Right, here's the 1 of each, the 2t squared, and then the v squared. How are we doing? All right.